So I really appreciate being here, and I also appreciate that you have to listen to me in English. And often I speak way too fast. Is that going to be, is that going to be a problem if I talk way too fast? We'll see how I'll slow it down, but maybe I'll speed it up. But we have a lot of things to cover, and I want to show you a lot of different things. I have a lot of different demonstrations of technology that I want to show you in this presentation. But if you guys could help me out a little bit, how many people here have been hands-on with Docker at this point? You've done Docker containers, fantastic, right? So that's most of you. How many people have been hands-on with Kubernetes? Kubernetes, okay. A lot fewer of you, but some of you have been familiar with Kubernetes. We're not going to spend a lot of time talking about Docker or Kubernetes, but those constructs are important to understand, and it's very important to understand why we did what we did. Now, I have another key question for you. I know that here at JokerConf, you guys are very kind of hardcore JVM, internals, folks like that. That is actually not my area of focus. My focus is on what you build on top of the JVM, what you build with the Java programming language, and mostly how do you enable building new software applications for a business. How many people here build web applications or APIs on top of the Java application? All right, fantastic. So you guys are my people, because we're going to talk about how you build applications on top of the JVM, not in the bowels of the JVM or trying to tear apart the garbage collectors or anything like that. We're just going to assume that stuff works, as the underlying platform should. So we're going to talk about what we do, a technology called Quarkus. So you're going to hear about Quarkus today as a new technology that was just kind of born this year, and we're going to have a little fun with it. But first, I want to give you a little history lesson, if you guys will just bear with me a moment. I want to tell you a little story, kind of take you back in time a little bit. As a matter of fact, we're going to take you back to 1993. And this is actually the year that Red Hat was born. So I work for Red Hat. I was acquired as part of the JBoss acquisition in 2006. So I've been there 13 years now. So I was part of the JBoss team and then part of the Red Hat team. But Red Hat existed long ago. It started in 1993. And it gave birth to this thing called Red Hat Linux in 1994. So that's what Red Hat is very well known for. So you might even be thinking, well, Red Hat is Linux. Does anyone have that perception? Red Hat, Linux? OK, fantastic. Right? Because certainly we love Linux, but we're not only Linux, and that's a key thing to understand. All right? We also focus very heavily on a couple other technologies. One is this thing called Kubernetes, otherwise known as OpenShift, and the other is Java. All right? So if you look at our little special Duke there, we focus a lot on Java. We have the OpenJDK team at Red Hat, and we also do a lot with Java middleware technology and enabling Java applications on top of Linux and Kubernetes. It's a big focus for us. So I want to take you also back to 1999 for a second. In 1999, if you had to build a web application, a new business application, and you had to write hello world to display to the web, it cost you $500,000 to get started. It was expensive back then. Now, I know many of you, I see a lot of young faces here, so you guys weren't in the software industry back in 1999, and you've been actually enabled by the concept of open source. In other words, with open source technology, you spent $0 to build your very first web application. You spent $0 to build your very first Java application. That was not true in 1999. We spent $50,000 just on the IDE alone. We spent tens of thousands of dollars on BA WebLogic back then. So this is before the age of open source. So just keep that in mind. Okay? The reason this is important, though, because in the new era, you actually pay these kind of prices now. You pay 25 cents an hour. You pay 8 cents an hour. You pay 12 cents an hour. It's a very different model from what we used to have. All right? In the old days, you would actually have to spend enough money to take advantage of all that hardware that someone had purchased. Okay? Meaning you would have to spend a lot of money on hardware, and you spend a lot of money on software just to get started. Now, you rent those computers and often the software stack for so many cents a minute. So keep that in mind. That's going to be an important topic. Also, if you look at this chart here, I want to walk you through the history a little bit as well. You can kind of see Java was born here in 1996. It was born before Linux became popular. It was born before virtual machines became popular. It was born before the cloud even existed as an idea. And it was certainly born well before the Linux container, that Docker Linux container became into existence. So you see Java was born way back here in 1996. You can kind of see the Agile Manifesto in 2001. 2006, as I mentioned, is not only when the cloud was born. Amazon gave birth to EC2 as well as S3, but that's when JBoss was acquired by the Red Hat team, as an example. So in that early 2000 phase, right, we had struts, we had Spring, we had Hibernate, we had JBoss that fundamentally changed the way we build applications at that point in time. You no longer had to pay $500,000 to get started. You could pay $0 to get started on your new application, right? Tomcat was born in that era as well. And so you can kind of see what was happening now in 2010, 2012. We have the concept of Vertex, Drop Wizard, the concept of building a new fat jar and having a single executable jar with all our application logic inside it. That came from Vertex and Drop Wizard. Also, microservices became a term in 2012 there. But it really got interesting in 2013 and 2014. 2013 is when we saw the birth of Spring Boot. We saw the birth of Docker. We saw microservices officially defined. And in 2014, Kubernetes was born as an open source project. So I want to just kind of walk you through that history a little bit, because you're going to hopefully have a feel for why we've done what we've done. So in 2014, Red Hat jumped on board that Kubernetes project in a big way. We're still the largest external contributor to Kubernetes as an organization. And that is definitely a focus for us as far as underlying infrastructure goes. So Kubernetes and OpenShift has been a big deal. As a matter of fact, we actually gave birth to this presentation in 2015. If you actually go to the YouTube video, you'll see me on stage showing this concept of a Linux container to the world for the first time. And we wanted to make a point at this presentation. We wanted to make a point that the Linux container was fundamentally different than anything you've seen before. So we launched 1,026 containers live on stage in 2.5 minutes. In other words, we gave 3 times as many people in this room their own app server in 2.5 minutes. And this was game-changing. If you think about it from an IT standpoint, normally we wait weeks or days for a new infrastructure service. We would wait a long time to get a virtual machine with an app server on it. In this case, we stood up 1,026 in 2.5 minutes. Now, here was the gotcha. We couldn't do this with Java. Java was too slow. We did it with Node.js. And so we have been thinking about this problem for a long, long time. I personally worked on this project, and we were basically trying to push it for Java, and we could not get it done. With a JVM, launching 1,000 of them would have taken many, many, many minutes, if not hours, actually. But we did it with Node.js, so keep that in mind. All right? So we gave birth to this thing called Quarkus in 2019. We've been thinking about that problem of what does it mean to build applications that are so lightweight that you want to write them in Node.js instead of Java, or you want to write them in Go instead of Java. And we had customers telling us all over the place, right? We have tons of customers at Red Hat, and they're telling us, we want to do microservices, we want to do serverless architecture, we want to do lightweight container-based orchestrated applications. We're rewriting all our Java apps into Node, or rewriting all our Java apps into Go. We kept hearing that time and time again. And for people who are on the Java side of the house, like myself from the JBoss perspective, this upset us. We did a presentation. We showed you we could launch 1,026 containers, but we couldn't do it with Java. And so we were seeing a trend, and we had to react to that. And so this is what you're going to hear about in this presentation, this thing called Quarkus, right, is our focus. And for those of you who build business applications, it's going to be a lot of fun. So that's our supersonic subatomic Java. That's the tagline for it. You might have seen this before, this quote before, if you're familiar with Mark Twain. Mark Twain, an author from the US from many, many years ago. Famous quote, basically talks about the fact that the reports of his death are greatly exaggerated. In other words, he's not dead yet. And so that's important because we've been talking about Java being dead since 2006. This is the earliest report of it I could find. But even this one right here, Ruby on Rails. Ruby on Rails is going to put Java out of business back in 2006. You guys remember that? Anybody still doing Ruby? No? Maybe not here at a Java conference? But I can tell you that the whole Ruby thing kind of came and went at this point, right? Now the new thing is Go, or Rust, or something like that. But it doesn't matter. Java is still doing incredibly well. As a matter of fact, if you look at these items here, you'll see that Java is still number 1 or number 2 in the various rankings and people who look at the language. In other words, there's still more jobs in Java. Java jobs still pay better than most other jobs in any other language category. And Java is doing incredibly well. So we had all these customers saying we need to rewrite our apps in Go, or rewrite our applications in Node, yet Java is doing incredibly well. So here was the challenge. Java as an ecosystem has grown up assuming a couple of key attributes. Okay? One, we'd have all these amazing open source libraries, all these amazing utilities and tools that made one key assumption, that you could basically scan the file system, load all the little jar files and class files you find there into memory, look at all their annotations and metadata, and build a meta model out of that. And that takes a lot of time and a lot of memory that cannot be reclaimed. So think about that. It has to read the file system, find this, find this, find this, all this stuff you're not even using, including the stuff in the JVM itself that you're not using. You're not using that web server that's built into JVM. You're not using that, XML parser that's built into JVM. You're not using, whatever it is for Swing that's built into JVM, that client-side library. But all this has to get loaded. So it actually takes a lot of time. So once you're thinking about that, keep that in the back of your mind too, because that's a key thing that we've done here. We've found ways to basically not load everything into memory at runtime. Okay? So the challenge you have is with all these flavors, all this goodness, all this stuff in the ecosystem, you keep adding all this good stuff, and you put on weight. This is true of humans, is it not? If you keep eating all the good stuff, you will put on weight. And this actually matters when you stick this thing in a container. So we noticed this a couple years ago when we did have customers basically putting Java in a Linux container and running it for the first time at scale. You might have actually seen this issue if you've actually run Java in a Linux container. When you apply C groups to it, meaning constraints to basically say, hey, in your container, you only have this much CPU and only this much memory. The problem was Java was built long before the Linux container existed. It did not respect those constraints. And so at this point, you probably are getting an out-of-memory killed, OOM killed, in your log file. The good news is if you have a Kubernetes or an OpenShift, it just restarts it for you automatically. You don't have to think about it. But if you look at all these restarts, you need to be wondering why is it restarting. And by default, depending on the version of Java you have and the base image you actually picked, right? So if you pick a base image from Docker.io, Docker Hub, it might actually still have this issue in it. It might actually be out of memory killed on a regular basis. So it goes boom. There's a whole presentation I've done on that basic topic. But it is a Linux kernel issue. It's a C groups issue. And Java had to respect it. And it doesn't respect it by default. All right? It does in Java 11. But in Java 9, 10, 9, and 8, they've been backporting the patches into older versions. It's probably about, I think it's Java 8, about the 200 level, somewhere in that range. I actually should know the number, but I can't remember off the top of my head. If you go back to 151, 152, it still exhibits the same bad behavior. Okay? Of course, if you run this at scale, you really start noticing that there's a problem. There's a lot of memory consumption, a lot of CPU, a lot of things are dying. So you got to keep that in mind. So at Quarkus, we really focused on these issues. We focused on the fact that we had a situation where we wanted to launch 1,000 containers. We had to do it with Node. We talked to all our customers who were doing Linux containers. They're doing it with Node.js or Go. And we had to think about that a lot. Why can't we do this with Java and kind of make it awesome and make it scale and scale up from 0 and back down to 0 in an elegant way? Okay? So we're going to talk about that. We made it optimized for Kubernetes. We've optimized a lot of different frameworks as well, because that's really where the issue was. All the frameworks assumed it could scan the file system, parse XML files, load things into memory, look at annotations, and build a meta model. Well, you don't actually have to do that at runtime. You can do that at build time. And that was really the secret sauce here. Do it at build time, not at runtime. Because it's easier to wait on the build than it is to wait on that thing to scale up in production. And hopefully we'll make that sense. You'll see that in the presentation, in the demonstration. OK? So a couple of key programming models and APIs. This is built on the concept of microprofile. Hopefully, how many people here have heard of microprofile at this point? Besides Roberto, who's doing a presentation on microprofile right after this. So you want to check out the microprofile presentation. I'll show you a little bit of microprofile. So this is unfortunate. Not too many people have heard of it. But the concept is it's very straightforward. It's the standardization of all those RESTful things that you want to do, the database connectivity that you want to do. You might remember this thing called Java-EE back in the day. It's a lot of those same kind of ideas, but modernized to the microservice world. So in other words, you have health checks, you have monitoring and metering, you have circuit breakers, you have all those kinds of things in a microprofile specification. So we implement microprofile as one example. But we also implement Spring Web, Spring Data, Spring DI as well, build that on top of it. We also implement Camel with enterprise integration patterns. So if you have to talk to other things, let's say multiple REST endpoints simultaneously, talk to Salesforce.com, something like that, you got Camel. Maybe Vertex for a reactive programming model using RX2 or completion stage and reactive streams. So you'll see a little bit of that in some of the code samples I'll show you. Reactive messaging is a brand new specification that actually is very interesting because it allows you to do inbound, let's say Kafka, and outbound ActiveMQ, or vice versa, or Kafka to Kafka or ActiveMQ. So it's a really great streaming programming model. Then there's BPMN, all right? Business process modeling notation, or DML, decision modeling language. So in other words, we're working really hard to bring all these different programming models and APIs and frameworks to this different platform called Quarkus. All right, here's microprofile at the top high level. You can see tracing. You can see there's the concept of open API, JSON, obviously, JAX-RS, JPA, right? All the things you need for a typical microservice application as part of microprofile. Here's an example of the actual an example of imperative and reactive. So in other words, the imperative programming model on the left is the norm, right? You typically have a get, put, post, and delete, and you wait for that thing to respond. Or you can have an asynchronous response and a reactive programming model as well. Maybe like a server-side event, where that message is actually being published to a Kafka topic and then pushed to the browser instead. So a different model. But you can do both inside a single application. You can do both inside the single Quarkus runtime. So let's actually kind of show you some fun stuff here. It's much more fun if we can actually write a little bit of code. But let me put on these glasses so I can see properly. And let's actually have a little fun. OK? Yeah, let's come over here. I got a bunch of things running. I have a bunch of things like, I have a bunch of, come on, Burr, type. We're going to see these in a second. Let's see here. I have, if my network holds up, fantastic. So I got a bunch of things already running out here. I've got Knative, I've got Kafka, I have Kubernetes, obviously. So these things are all running. But right now, let's just kind of build a little simple application. OK, let's just call this thing Joker. I'm going to switch over there. Let's see. You can see that, like a magician, there's nothing up my sleeve. There's nothing in this directory at this point in time. So let's actually build a little application. Now, there's multiple ways to get started with an application. One is there's a Visual Studio Code plugin. We could go look at that. Another is there's a code IO example. Let's see here. Is it over here? Yeah, code.quarkus.io. So you could use that. And again, you can kind of point and click your dependencies there. But one I like is just simply using this one command for the Maven plugin. I'm going to highlight it and Control-C. And I'm going to come over here and paste. And we're going to call this thing, we're going to give it a namespace. All right, Joker. And let's call this thing Joker. And snapshot. And let's go ahead and just give it a REST endpoint out of the box. Let's go bring up Visual Studio Code now. So I bring up Visual Studio Code. That's my favorite tool at this point in time. I like the fact that it's a lightweight editor. And you might be familiar with the fact that Red Hat helped contribute the Java language support, this right here. So you'll see that we did a lot around Java, specifically around VS Code, also around YAML for use with Kubernetes, as well as Quarkus. There's a Quarkus tool built in here and all kinds of other tools. Let's kind of come in here now and actually look at this application that was created for me. Let me also bring up my terminal. OK. And this is a simple little JAX-RS endpoint. But let me put this thing into development mode. One of the things we very much focused on was the concept of developer experience and developer joy. What does a developer need to do to build a new application endpoint? In this case, I just kicked it into developer mode, which gives me one simple little feature. And let's just kind of look at it here. Let's go to localhost 8080. This says hello. OK. I can hit refresh there. It says hello, no big deal. If I come over now and say, let's make it say bonjour, edit, save, refresh. Bonjour. Edit, save, refresh. Let me come over here now and say, make it say aloha. I'm originally from Hawaii, so I'll say aloha. All right. Edit, save, refresh. So that might seem trivial. Some of you might be familiar with some older plugins for IDEs and things like that. But this is built into the core runtime. You can basically treat it like it's Node.js. As a matter of fact, we learned this lesson from the Node.js development community. They basically work this way. They write a little code. They hit save. They hit refresh. Java people will always do a build and go get coffee while the build is running. In this case, you now can basically interactively build the application. And I even tried to figure out how to say hello in Russian. I could not, privet, something like that. But let's just copy and paste it, make it a little bit easier. And then edit, save, refresh. OK? So I don't have to take down the server. I can just hit edit, save, refresh. So that's one key concept to keep in mind, right? Edit, save, refresh is a key model for you to basically build up your application interactively. This works both for Java files on the server side, as well as application properties, meaning changing in the configuration, as well as HTML, JavaScript, CSS changes as well. So you really can build a whole application just simply going back and forth, edit, save, refresh. Maybe use a curl command to do that refresh, or refresh in the browser. But that's a simple little application. Let me also, though, fix my test case, because I'm going to have a test issue. We do give you JUnit 5, as well as rest assured here for doing basic testing right out of the box. So if I hit run test here, I can run that test interactively. It also starts a server on 8081, separate from the one that I'm interacting with right now. That way it doesn't actually have a port conflict. But you can see it says hello, but we have the Russian hello here instead. So let me paste that in. Close, save, and run that test one more time. And in this case, we should get a nice green checkbox because we should have the right one. Very good. We have a nice green checkbox. So you can do your interactive testing the same way, right? So if you're practicing TDD, right, test-driven development, that might be a solution for you. But let me now do something else. I want to actually show you how we can add an extension. And so there's a couple of ways you could have done this, right? I could have come over here and said I wanted JSON-B as an example. OK, if I could type, right, JSON-B. But I'm going to do this more from the command line again, because I prefer the command line. So Maven Quarkus list extensions. So you could do this either way. You can kind of point and click, or you can basically add them this way. And I'm just going to simply say, yeah, let's add some new extensions. And it helps if I don't have that extra tick there. There we go. And so what we want to pick is a bunch of extensions, and these have been optimized to run in this new small, fast world that we're talking about, all right? So these are things that have been optimized. Pretty much everything that runs on the JVM still runs. But if you want to be optimized to go all the way down to a native executable, the ultimate in size and speed, then you have to kind of use one of these that have been optimized for that. And we'll kind of explain more of that in a second. But let me go ahead and pick the JSON-B here. There we go. We'll get that one. And then I also want to pick Postgres. I like using Postgres. It's my favorite database. And then I also want to get this thing called Hibernate. And oh, yes, let's get Hibernate Panache. And a lot of people don't realize this, but the Hibernate team is actually part of the Red Hat team. And this was the first project that we experimented on internally before we gave birth to Quarkus as an idea. Hibernate is a massive open source project. And could you actually make it compile to a native executable with GraalVM or not? It turned out it was a lot of work, because Hibernate did make certain assumptions. It assumed it could load everything off the file system, and it assumed it was going to parse an XML file. You remember HBM files for Hibernate? It assumed it was going to parse some XML. It assumed it was going to build a meta model out of reflection, and it also did all the annotation scanning. Well, it didn't have to do all that, okay? Especially for a modern application like a microservice. It did that for the old days of WebSphere and WebLogic and JBoss, but it doesn't have to do that for a microservice. So let me hit no here. Go ahead and put it back into dev mode. And OK. And yeah, so let's go ahead and get started. OK, so now let's build our application. So let me add something here. I'm going to add a to-do.java. This is going to be a new class. And I'm going to say @entity. OK. Dun, dun, dun. Yep, we want entity there. Fantastic. So let's build our entity. Public string title. A to-do has a title. Boolean completed. It's marked for completion. And also let's make it have an order as well. Now, in the case of order, that is one of those things that actually collides with the database. Oh, I didn't want that. It actually gets you in the database, right? Because order actually means something over in the database. So let's actually give this a different name. And this is basically a little JPA. Let me get rid of that. All right? A little JPA, Java persistence. No big deal. And normally at this point, right, you would come in here and you would say, OK, I could use my Visual Studio Code. I could basically say generate getters and setters, all that stuff. But I won't. I'm using this thing called Panache instead. And so this is what we did. The goal of this was to make Hibernate easy, to make it more like Active Record or Ruby on Rails or something like that. So I'm going to say extends Panache entity instead. And then I don't have to do anything else. I simply have to declare my values there and hit save. OK, save, and let's go to refresh. All right, edit, save, refresh. And we get an error. Oh, boy. Let's see here. This thing is, OK, yeah, there's no JDBC driver configured for that thing. Okay, that's true. I don't have a JDBC driver configured. Let's go and configure one. That is going to be in my application properties.file here. And I can say Quarkus, and I can start dropping these things in. But for the sake of speed, I'm going to just paste them in. All right, so let's go paste that in. Dun, dun, dun. And let's call this thing Joker. All right, so Joker. All right, and Joker, edit, save, and let's refresh. Let's try it again. And again, I get an error because, let's see, what does it say? Oh, there's no password for DB Joker. That's because I need to go actually create that on the database side. So let's do that. Create here in my pgadmin, DB Joker. Copy that, define it, password, and make it a super user who can log in, just to make this easy. And let's build a blank database to hold our schema owned by DB Joker here, and hit save. All right, and so edit, save, refresh. Okay, in that case, we just edited our database. But now it can actually generate the schema, okay? So in other words, we now have this database here called DB Joker. If I look at schemas, I look at the actual table. There's a to-do table with columns, and you can see there's the column. So the schema's been generated. Now, this is a Hibernate feature, right? We've been doing schema generation on Hibernate forever. But the difference is how easy have we made it to use, okay? And so now you can basically start building out your schema that way. That's actually good enough for my schema. Let's go ahead and actually add some business logic to this application. So I'm going to say to-do resource.java here. Let's build a class file. This is going to be a JAX-RS endpoint, so let me put path on here. So just add path, and let's call this API. It's going to produce, and it's going to produce application media type. Come on, media type. There we go. Application JSON. Got to go. All right, there we go. Consumes, and media type again. Application JSON. So in other words, it's going to have inbound JSON, outbound JSON. That's pretty straightforward there. Let's get our imports sorted out. There we go. Okay, that's pretty good. So the first thing you want, if you're doing create, read, update, delete, right, is read. Typically, read is the good one to start with. So that's at get. All right, so get. And I'm going to say public. And I want to return a list of to-dos. And say get all. There we go. Oh, we got another import to fix there. Yeah, there we go. Okay, and we're going to return to-do and list all. So it has a method there for returning all of them. Also, you can do filters and things like that, right? There's a query language, but we're going to ignore that for now. Do something very simple. And then let's go look at that. So this is API. So back over here. So we have our hello. That's no big deal. Look at API. All right, and it's just an empty array. There's nothing in the database at this point in time. But let's add something. So we got to do that. To do a create, we do a post. Okay, a post needs to be transactional. And we're going to say public response, add one. We're going to add a to-do item. Yeah, that looks right. Okay, so we're going to say item.persist and return response. And we're going to return the response of, yeah, it's going to be status. Yeah, status. Whoop, don't need that extra set of parens. Yeah, created. There we go. We're going to make it created. We're going to return the entity that was created, which is item in this case, and we're going to do a build, and that's going to be our response. And if we did everything correctly, okay, now we just have to do a post. I could do that with a curl command, obviously. But in this case, I actually have a bit of user interface. So let's go ahead and get what the front-end designer did for me. And I don't know if you guys are familiar with this front-end design place. It's called To-Do MVC. And maybe you've heard of them before. They're out on the internet, and they build to-do user interface and all these different client-side technologies like Vue.js, React, Backbone. So I have the Vue.js one locally here. So let me go ahead and get that open again. OK, here it is. So I'm just going to copy and paste this over. Let's see here. We're going to copy. And I'm going to go to, where did we call this thing? Joker, right? So the Joker project, source, main, resources, meta-inf, resources. And I'm going to just overlay the index file that's there and replace it. All right, come back, edit, save, refresh. But we need to go to the root, and there's to do. OK, so 1, 2, 3. There's our user interface there. Let's go look at our database. And you notice I'm going back to the database user interface a lot. This is because I'm old. In other words, I actually grew up in the early days of relational databases. And we basically had this concept of the database is such a new idea, and it was separate from your application logic process, that I always had the habit of checking, did the database reflect what my application code said? Because often it would not. The connection would be lost, right? The data would not be transacted correctly. The transaction wouldn't complete. Therefore, the data would be lost. But you can see in this case, 1, 2, 3 are in the database. OK, 1, 2, 3 are in the database, so that's cool. So my add is there. Let's go ahead and add a couple other features to this application. OK, let's add a delete to it. OK, delete. It also needs to be transactional. And in the case of delete, it has a path. It has a ID. Whoop. Yeah, ID. There we go. Public response. Let's delete one. And it's going to be at path param. ID. Long ID. And yeah, that looks pretty good so far. All right, so it's going to have to do entity. Let's say, yeah, equal to do find by ID. Find by ID, there it is. ID. Yeah. Okay, entity dot delete. And let's return a response. In this case, we're going to just say no content, right? That's a simple one. We're not going to return anything. We just did a delete. And I hit save here. And so if I did everything correctly, okay, if I come back and hit refresh over here, all right, 1, 2, 3 again, 4. Let's look at our database, see how it came out. You notice, by the way, that all the records went away, and I'll show you that in a second. But let's see, there's 1, 2, and 3, and 4 in the system right now. And then let's do some deletes on them. Let's delete 1 and 2. And then refresh again over here. And so 3 and 4. All right, so my delete's working for me. Now, but you might be wondering, why did my data go away? And it's actually very straightforward. In this case, if I have my application.properties file set here, you can kind of see it does have the Hibernate flag of drop and create. So every time you refresh, it's actually recreating the stack. The whole application is actually being refreshed, including drop and create is being re-executed. You can switch this to update or none if you want to keep your schema around. But if you're doing interactive testing, it's actually nice to have a clean, fresh database whatever time you refresh or every time you start, every time you test. But let's actually add one more little component to this. And we're back over here. OK, so one more command. It's a lot like this one, so I'm just going to copy and paste this one. And that is the update command. It's actually known as patch in this case for that user interface. Patch and transactional path, and we're going to update one instead of delete one. And we're going to basically send in the to-do item. OK, we're going to find it, and instead of delete it, we're going to say entity dot completed equal to item dot completed. Fantastic. Entity dot ID equal to item dot ID. All right, really good. And order, item.order. So this is the data coming in from the user interface, coming from the GUI, and item.title. OK, looks like I did that about right. And return response. In this case, we want to return the actual entity that was basically created. And I think I did that OK. All right, let's look at it. Edit, save, refresh, right? So we saved, refresh. So 1, 2, stuff happens. Let's go check our database. Refresh over here, too. Look at it. And there's 1, 2 stuff happens there. Let's go see if our delete works. Let's delete 2. Let's update stuff here. Love Java. OK. And this one, learn Quarkus. All right. And refresh here again. There it is. So there's our database updates. So create, read, update, and delete is pretty straightforward. You can actually do a lot more with this. In other words, you can actually have validations and things like that. But let me show you one more thing, OK, about this particular application. Let's hit Control-C here. Just go back to my command line. I'm going to say Maven Package now. So I was doing all that in the interactive development mode, right? So let's say I'm done developing. I've built my test, though I only have one little test in there. I've done everything I think I need to do. So now let me package this application for like a production environment. And when I say Maven Package, you're going to basically have this. You're going to basically see that there's this new runner jar that was created. So there was the jar, the original jar, but then a runner jar has actually been augmented to execute not as a fat jar, but as a thin jar. And actual, if you can see, it's only 1.3 megabytes. It's a very tiny little jar because the actual dependent libraries are actually over here in this lib folder. So whenever you pick up a Quarkus app and move it to your Docker container, you actually take 2 things: the runner jar and the lib folder. And we did that for another optimization. If you actually do a lot of Docker builds, it's rare for you to actually update your underlying dependencies. You typically are updating your code a lot, but not your underlying dependencies. So keep that in a separate layer, as an example. OK, so that's why we do that. But if I come over here now and say, let's run this thing, OK, let's go ahead and run it. And there's our application up in 1.458 seconds. So that's pretty awesome, a complete application up in 1.458 seconds. But let me do this now. Whoop, come on. Whoop. Shrink back. OK, there we go. Control-C. Let's do this now. Maven, and then package. p native. So now, let's actually make this a GraalVM native image. And so we have a plugin built in. The plugin came with the rest of the application when I did the original create. Let me do an echo here. I think I have this environment variable set. But you can see I'm using the GraalVM Community Edition 19.201 right there. So that's what's being set, and it has that native image compiler built into it. Now here's what's happening underneath the covers, and it'll take a few seconds here to actually finish this up. But it's basically scanning the entire class path of the application and looking only at the runtime execution, meaning what paths are being called. And it's going to chop out everything that's not being called. In other words, the whole of the JVM doesn't have to come along. The whole of Java-E doesn't have to come along. It only needs what it takes to run this little application. If I were not using Hibernate, there'd be no Hibernate. Just because Hibernate's in the class path doesn't mean it's going to be put into this native executable unless we are actually using Hibernate. More importantly, if you've used Hibernate before, right, you might use Hibernate to talk to a MySQL database. But did you know you're also carrying along the connection pooling technology and the connectivity technology for Postgres and for Oracle and for DB2 and all the other databases Hibernate supports? So now it's been optimized just for Postgres, since that's all I'm using. I don't have to carry the 400 classes that reference Oracle with me any longer. So this concept of what's happening right now is called the closed world view. In other words, we're taking a view of that application and we're making assumptions about it at runtime, and we're putting it all into the build time capability. In other words, we're doing the complete code elimination and creating that thing for build time. And so, see, it takes about a minute to 2 minutes, depending on the type of workstation you have, and depending on the type of build you're doing. So this will be now it's done. But here's this application, OK? Wrong window. If we look here, there's the runner, so that guy right there. So let's go look at it. And it's this one right here. And it's 54 megabytes in size. And that is everything you need to put on a flash drive and run wherever you want it to run. OK? Wherever you want it to run. So that's the whole application. No JVM required. If I say Java target, and let's go ahead and run it, right there, it started in 0.049 seconds. This includes, and this is not lazy loading, by the way. We're going to be anti-lazy here. We don't do lazy. We do hyperactive. I'm kind of hyperactive. This basically not only configured the database schema and generated all that for me, it created the connection pool. The whole app is up and running and ready in that time. It's not waiting for the first request. OK? So the whole app is up. So if I want to come back over here and look at it one more time, let's go over here. Let me refresh. OK, I know caching pages. There we go. Come on. Oh, it thinks I've cached something here. OK, I know what to do. You know, this is the problem with cached pages. So incognito. Wow, come on now. This is the old page. Where'd the old page come from? OK, I know I have something in there that's not clean. So that's what we have to do is kill it. We'll just remove it. So basically, I have the old page still inside there somehow or another. I'm not sure where I did that. Did you guys see where I did that? Or maybe I left it in there. But that is the original page that I overlaid with my to-do screen. So we don't have to worry about that one. But if I come over here and say curl, localhost 8080 API, right? So there's the empty array. There's nothing in the database. If I do my post and things like that, I can interact with it, kind of thing. My user interface is a little bit messed up. But many of you here basically said you didn't know microprofile. So how many people here know this syntax and use this syntax, besides Roberto? OK, well, let me show you this. OK, we're not done yet. How about this version of the syntax? As I mentioned earlier, we're working with other programming models. So very well could be that you might have this thing, instead of an @inject, use @autowired. Instead of @get, use @getMapping. How many people use this syntax? Aha, so this one looks more familiar to you, right? Same kind of thing applies here. If I come over here and say, I already did the compilation on this one. So let's see if it'll run for me. I haven't tested it in a while. So spring to do, runner, OK. Started in 0.2 seconds in this case. And let's see if this one will come up for me. Let's see here. I can't remember what the URL I gave it. OK, I know. You still think it's something. I have something. Oh, I know what it is. Do I have that other thing running on 8080? Sometimes I leave something running on 8080, And that messes up. No, this guy's not running. So, okay, maybe this one had the different URL. Happens. And let's see here. And which one did this one connect to? Which database? I think this one connected to my Kona database. And let's see, refresh. We'll find out if this is the right one. Yep, one stuff happens, all right? All right, but that's an example of a Spring-based user interface or a Spring-based API that might be part of what you want to do there. Also, we've done some other things that are pretty interesting from this perspective. So there's your Spring, but we also have this concept of reactive messaging, okay? So let me show you reactive messaging. And reactive messaging looks like this. It has the concept of at incoming and at outgoing. So if you actually are taking in a stream and you want to manipulate that stream and output yet another stream with back pressure, using a reactive programming model, you can do that too. So you could do that with WebSockets and SSE if you're going back and forth to the browser. It doesn't actually make a ton of sense if you're just doing get, put, post, and delete, like my CRUD example. But in this case, it could be Kafka transactions flowing to the system also. So in this case, it's doing a simple map. And here, I'll just run this demo real fast. We have some other things I want to show you that are much more interesting. So this one's running over here. Let me just bring this up. This actually runs a ton of little application servers, a ton of little microservices on my system. Oh, and I have something running on a port that's complaining about. There we go. Come back over here, had that guy running. Dun, 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 dun. Get that running again. So I can actually put all these little servers in dev mode. And I can actually change the logic across any of these things and interact with them and just refresh. In this case, I'll just show you something very simple. Let's see here. This should be coming out the other end. I have a little stream here. Yeah, let's see. OK, good. And let's make this a little bit, change the shape of it here so you can see things a little bit. But let's do a produce and get this window back up. Where to go? There's a problem with this little demonstration. There's just too much going on. Okay? But in this case, if I push messages in, you can see it streaming back out the other end. If I come over here and actually look at the code, it's simply doing the aloha dude. It's replacing the inbound JSON completely with something, a different transformation. If I come over here and just comment this out and actually do something a little bit more interesting, let's say we want to filter messages as well as transform them. Okay. Yeah, this is an example of that. And you can kind of see what's going on here. But let me also, so I just basically edit saved, and I got to do a refresh now. If I come over here, let me see, I have a little reset, which basically does the refresh for me. There we go. Now it's reloaded. And where'd my little, oh, I lost my window. OK, this guy right here. In this case, it's filtering only for orders that end in a certain number. All right? Basically, if it ends in 8, then it basically says it's a special customer. But this is just another example of a different programming model, okay? So this is another way to kind of interact with the application and build something new. But I want to still show you something more, right? This is not the super cool stuff yet. Do you guys think this is cool? I got even cooler stuff to show you, so hold on. Okay, instead of watching me hack here, I'll show you some other things. But let's kind of walk into this. We're going to quickly just mention Kubernetes, okay? We built this for the modern cloud-native world where you're dealing with the concept of Kubernetes or virtual machines, and you're paying for that memory by the hour. So memory footprint is something you now notice on a monthly bill. When Java was born, it did not matter. Okay? You basically bought the machine, the physical machine, and the memory that was in it was the memory that was in it. If it cost you $10,000 for a memory stick, you paid for that. Now you pay so many cents per month, per hour, based on that. So with Kubernetes, you have to have that same kind of mindset. I might have Kubernetes, which has a master node, which has the etcd database, and it has this API. We're not going to spend a lot of time on it, but it has all these worker nodes, and these worker nodes are where the work gets done. The worker nodes are where my pods get scheduled, where my application services get scheduled, like a Tomcat, a Wildfly, a Spring Boot, a Python application. It doesn't matter what it is. As long as it runs on Linux, it can be scheduled out into a Kubernetes worker node, okay? And so if I actually say I want 2 of something, like 2 of this customer service application, it'll basically put 2 of them out there. So you can see 2 of my little Tomcats appearing here, right? So 2 little Tomcats. And also, it's constantly monitoring. So if anything dies, you can see my Tomcat there died, it'll basically find a new home for that Tomcat, as an example. So this concept of dynamic scale-out or dynamic rescheduling was important to us, okay? And that's what we thought about why we built this super small, super fast Java, still with all the enterprise capabilities you're used to run business rules, business processes, APIs, that kind of thing. So let's kind of show you this thing. I want to show you a couple little demo applications that I have here that hopefully give you a little feel for what we're talking about here. Here's a little serverless application based on something called Knative. I say kubectl, get CRDs, grep. This should give me some Knative results. So Knative is a serverless architecture, serverless framework sitting on top of Kubernetes. So I have Knative installed here. I think this one might also have Kafka installed. Let's see here. OK. So that's actually one thing that's pretty awesome about Kubernetes. A lot of people don't know this. You can extend the schema and the API of Kubernetes very, very easily. You can add Kafkas to your cluster. You can add Knative, Istio. You can add pizzas. You can add beer. It's actually very easy. You can actually have anything you want added to your schema. In this case, I have Kafkas and I have Knative. And let's actually have a little fun with that. So I'm going to basically say, watch, kubectl get pods. And this is in the side-by-side namespace. Okay, I have no pods running. No applications are running right now. A pod is the actual instance of the application running. But let me come over here and say I want the Node.js application to come online. Let me also bring up my Quarkus application online and see what's happening here. Based on that inbound event, all this is doing is a curl command, by the way. A curl command is coming in, hitting a certain endpoint, and it's waking up the Node application, it's waking up the Quarkus application, and bringing them both online right now. You can see they're both going through their life cycle, and Quarkus nearly caught Node.js in that case. I started Node first. Quarkus came up, less than a second after it. And so you can see we've now made Java as fast and actually faster than Node.js. Okay, so that was the point. We launched 1,026 containers, remember? But we had to do it with Node. Now we can do the same kind of thing with a Java-based application. So in this case, I have my two applications running. Let me actually go look at my user interface over here. So this is all running on OpenShift, which is our Kubernetes version. But I have the metrics right here. Yeah, here we go. And yeah, let's kind of look at this. Okay, let's see if we can zoom in here. Let's see what this says. Oh, come on now. This is the unfortunate thing about this user interface. You get this little pop-up. There we go. And that is my Node.js application at 25 megabytes. You guys see that? And my Java application down here is at 13. So in this case, Java's half the size of Node. So that kind of blows your mind. So again, when you're paying real dollars for these services, this starts to matter. Okay, and when you're actually paying the money each month. So that's my Quarkus-based application. And if I run a regular JVM-based application, and by the way, Quarkus works fine on the JVM, OpenJDK, as well as it does with a native image compiled through GraalVM. All right, it goes either way. But if you run a regular JVM-based application, you would see that closer to the 70 meg or 100 meg, depending on what's in there. Okay, a regular Spring Boot application would be 100 megabytes, as an example. And I could actually, I have only a few minutes left, but I could even, let's see, I'll go ahead and bring that one up too. Well, we won't have time to wait around. It takes a little while to bring up. But, a little Spring Boot app here. And again, all I'm doing is hitting the endpoint. These endpoints are right here. Oh, limit in, side by side. Not OK. Get kservice in, side by side. There we go. All right, so even you guys could touch these endpoints from your phone, as an example. And it would wake up this infrastructure based on the event coming from your HTTP request. So that is the nature of serverless in this world of Kubernetes. If it's not being used, it gets shut down. All right, to kind of make that point, and the title of the presentation was How to Scale to Zero. Let's try that real quick. OK, there's my Spring Boot app running right there. OK, and let's go look at my chart. And so in this case, it looks like it's clocking in around 80, a little over 80 megabytes. Where's that little? Come on, there we go. Tooltip doesn't want to come up, but there it is. 91 megs right now. OK, so we can let those run. And what will happen is if I stop touching these endpoints, you will see these things go away. OK? By default, they go away after 90 seconds. Because that's what a serverless means. Do not pay for memory and CPU that you're not using. If there's no inbound event, shut it down. Shut down the application server. that is not being used. Now, this is part of the dynamic auto-scaling capability of Knative on top of Kubernetes. Kubernetes, of course, will auto-scale out the actual worker nodes, too. In that case, I don't have that turned on, but if I say get nodes here on this cluster, you can see I have a bunch of different, only 2 worker nodes in this case, and 3 masters. Masters always come in 3, because etcd needs 3. But let me show you a slightly different variant of this, okay? I mentioned that you can have Kafkas, get pods here. And what I've done is I've actually created a Kafka application. So let's do this, kube-ns, and this is demo. Let's switch. Here we go. There we go. So I have a Kafka cluster here. So I have my 3 Kafkas, my 3 zookeepers. That's the typical production setting for a Kafka environment. This is based on a technology called stremz. So just be aware of it if you're interested in running Kafka on stremz.io, I think. If you're interested in running Kafka on Kubernetes, this is the operator that does that sort of thing. If I come back over here, I could go to, let's say, operators. You can see it in the GUI as well. Everything I'm showing you with the command line, by the way, there's a GUI for this, but I'm just I like the command line. But, here's Kafka as an example. So you can have that stremz operator there. But that gives you access to Kafka inside your cluster. So what I've done with this little application is we're going to jam a bunch of messages into Kafka and then see some scaling based on that. So let me go over here, and we're going to look for pods that have this label. They're called Knative Sync. There are no pods running right now. Let me bring up the user interface for this. OK, right here it says 0. Let's make this a little bit smaller. There we go. OK, and now we just need to push in some messages. Let's go ahead and just crank it all the way up. All right, and go. So we're pushing in 1,000 messages right now. It's going to go into panic mode. 1,000 things just came in, like 1,000 users just hit our system. And what Knative does, it kind of says, holy crap, there's a ton of work that just burst in on us right this moment. So I need to start scaling as fast as I can scale. As a matter of fact, I'm going to start scaling to 10 concurrent application servers to respond to that load as fast as I can. 1, 2, 3, 4, 5, 6. Oh, crap, I got almost 10 up, but let's actually go to 50, because I have 1,000 concurrent requests coming in. Let's go to 60 if we can. And it basically tries to auto-scale dynamically as fast as possible to rapidly handle the load that came in unexpectedly. And so in this case, you can kind of see it's still scaling out. You can see these pods coming online. When you see pending, that means the scheduler is trying to find a worker node to schedule it to. That's what pending basically means. If you see it stuck in pending, it probably means you're out of resources on all your worker nodes, and it's trying to dynamically add new worker nodes by spinning up new virtual machines. In this case, this is running on Azure, and it's running on Azure over on the east coast of the US. My other example was running in Ireland on Amazon. But here we go. We're trying to get those pods online. It's working hard to get everything up. So we're not going to actually get to 1,026 containers in 2.5 minutes, but we might get to 108 in about 1 minute. And so the concept of being able to dynamically scale out based on unknown or traffic that was unknown at the point in time that we built the application, or we actually had to set up our infrastructure, means it will dynamically scale out on demand. This is based on Kafka messages. Earlier, the example I gave you was based on HTTP input. But now, based on Kafka messages, it can dynamically scale out. This is known as Knative eventing, and based on Kafka. And here we go. Can we get up to 108? 108, 108. All right. 1415. Made it. OK? And watch what happens. If we just actually talk for just a few more seconds, it's going to realize, OK, we panicked. We got 108 application servers up and running. But I don't actually need all of those to sustain the fact there's no more load. All the load came in one big burst. There's actually no more load, and it's going to start trimming it back now. And this is, again, a feature of Knative. But this concept of being able to dynamically scale out in response to overwhelming load and dynamically scale back to 0 when nobody is using that application was a big factor. The serverless architecture, right? You can also see this with Amazon Lambda, if you're into Amazon Lambda for a serverless architecture. How do you actually make Java respond in this use case, right, in this situation? And you can see it's basically trimming back rapidly. It's already trimmed back down to 1 node, that one right there you can see running, OK? And actually, if you ask the JVM, hey, what is the name of your host, it would actually report this information right here. That is its host name. That is the computer it thinks it's running on, the JVM running inside there, or in this case, the native image. It works the same way for JVM or native image. But you can see it's already gone down to 0. It shut down all those resources based on the fact it no longer needs them. So a couple more things that I want to show you, and then we can kind of wrap things up. Okay. Let's come here. So this concept of being able to have everything in a small environment, right? I can actually put a lot more applications in the same memory footprint and CPU footprint than I otherwise had before. So we actually have done a lot of benchmarking. You'll see benchmarks on Quarkus.io as an example. If you go to our website, you'll find different information here. You can see benchmarks that basically talk about what REST and a JVM-based application. So on a REST test, it went from 104 megs of RAM to 74 with JVM, 13 with native, with GraalVM native, right? JPA, same kind of thing there, 218 down to 130, down to 35, because the optimizations of not scanning the file system, not loading all those annotations, not building a meta model, doing it all at build time, not run time, have a huge impact on the memory used and the startup time associated with the Java virtual machine. Now, this is a tool, this concept of dynamic scale out and dynamic scale down, right, is you use that for this kind of workload where you don't really know your load. If you actually know you have an application that's going to be alive for weeks at a time, then maybe you would just use a normal JVM-based application in that case, okay? So just keep that in mind, too. And let me see here. Oh, one more thing. Okay. Yep. Just to kind of show you this, and then we'll be out of time. But again, we've been benchmarking. It's about 10 times smaller, about 100 times faster. You saw how we started up earlier. GraalVM and OpenJDK often gets lost in the conversation. People think, oh, it's only for GraalVM. And certainly it's super fast and super small on GraalVM with the native image compilation. But all those optimizations still apply on the JVM. It's just a little bit bigger, a little bit slower, or in that case, right, for the JVM. And again, if you have a long-running process where you really need some clever garbage collection and whatnot, you actually do want to use the JVM. And when I say long-running process, it takes about, what we've seen, it takes about 12 minutes to truly warm up the JVM for it to be fully optimized. In my case, I was starting and stopping my application servers in seconds, right? 90 seconds was as long as they lived. So I didn't even give it 12 minutes to do its optimizations. So you do have to think about that. And again, we showed you this as well. Do check that out on the website. And I will be available for questions afterwards, but we might have time for 1 or 2 questions right now. Or are we completely out of time? Or out of time, OK, so no problem. I will be available afterwards, but make sure you get access to the slide deck here at bit.ly Java20. All right, you want to get access to these little videos and recordings from different presentations, but make sure you actually have access to the slide deck, and then that'll get you access to everything else. And then I thank you all for your time. Again, it was my first chance to speak to the Russian audience, so I really appreciate it, really enjoyed it. And for those of you who build business applications, when you raised your hands earlier, did you get to see something super cool here? Yeah? Fantastic. Thank you.